Alright, good afternoon to everyone and welcome to another episode of Moyo Math as we prepare for our CSEC exam, and we will do classes every Saturday. Classes will be done every Saturday to help to prepare students for the exam in May, June of this year, 2025. Alright, good afternoon to everyone. So, what we're going to do today, we want to continue with algebra, so we'll be looking at algebra part 2, and the topics today we're looking at will be transposition, simultaneous equations, variation, indices, functions, and relations. So looking at CSEC past paper questions in relation to the topics just identified. So don't forget to like, share, and subscribe to the channel. Make sure you tell a friend, know the classes are free, come participate, be a part of it, and learn and prepare for this exam in May, June of 2025. So let's get into it. So looking at transposition, and the first says, if S is equal to a half into U plus V, of course U plus V in brackets, T, express U in terms of V, S, and T. So we have S is equal to a half, and in brackets U plus V times T. And when they ask us to express U in terms of V, S, and T, it means we want to get U by itself on one side of the equal sign. So we have to get U by itself, and of course we want to obtain an expression for U involving the variables S, V, and T. So how are we going to make U the subject? Currently U is not the subject, so we have to implement various steps to help us to make U the subject. So what can we do to make that happen? Now, we can do a few things. We can remove the brackets if we wish to, or if not, we can remove a half and T, then we can remove V to make U the subject. The aim to make U the subject is to get rid of all those variables that surrounds U. So what I'm going to do is to remove a half T first. So a half, this is the same as a half multiplied by T into U plus V. So a half multiplied by U plus V multiplied by T, even if I write it as a half T and in brackets U plus V, it's the same as above. So what I'm going to do is to remove a half T first, and we know from our knowledge of equations, the opposite of multiplication is division. So I'm going to divide a half T U plus V by a half T. And what we do to one side, we must do to the other. So I'm going to divide S by a half T also. So what is going to happen here? My a half T and a half T will divide into each other to give me 1, and I'm going to be left with U plus V, and S all over half T is the same as a half T can be written as T over 2. So a half T is the same as a half multiplied by T over 1, which is the same as T all over 2. 1 by T is T, 2 by 1 is 2. So let us, just format this properly. So S divided by T over 2, this S, the line represents a division operation. That's S divided by T over 2. And we know that in the dividing fractions, we change our division to a multiplication sign, and we invert the second fraction to become 2 over T. So we can express S over T over 2 as 2S all over T is equal to U plus V. And therefore, to make U the subject, it means now we have to remove V. So to remove V, we can subtract V from both sides. So therefore, this will be 2S all over T, subtract V. This is U plus V, subtract V. So when I subtract V from both sides, I'm going to be left with U, which is equal to 2S all over T, subtract V. And this is us making U the subject of the formula, or expressing U in terms of V, S, and T. So we have V, S, and T, U expressed in terms of those variables. Alright, let's move on to another. So express P as the subject of the formula. So we want to express P as the subject of the formula. Again, in expressing P as the subject of the formula, we want to get P by itself on one side of the equal sign. So we have Q is equal to P squared minus R all over T. So how are we going to make P the subject of the formula? What we can do is first remove it from its fraction form. We never work with an equation or solve equations where fractions are involved. So the aim is to remove our fractions first. So to do so, we can express Q as a fraction. We can express Q as Q over 1. And to remove a fraction, what we can do is carry out what we call cross multiplication. We want to have one fraction on the left and one fraction on the right of the equal sign. For example, A over B, C over D. To remove the fraction, one fraction on the left, one fraction on the right, I can cross multiply to remove this equation from its fraction form, multiplying A by D and B by C. So I'm going to apply the same here. I'm going to multiply 1 by P squared minus R. It doesn't matter if it's on the left or right side of the equal sign. So 1 by P squared minus R, sorry, if it's on the left, P squared minus R is equal to Q by T. So my fractions are gone, right? No fraction. What I can do now is to proceed to make P the subject of the formula. So to do so, I'm going to remove negative R, and I remove negative R by adding R to both sides. So negative R plus R will be 0. We have P squared is equal to QT plus R. And to make P the subject of the formula, it means I have to remove that power of 2. And how do we remove a power of 2? We find the square root of both sides. Yeah? So I'm going to put the square root symbol above P squared. That will automatically allow the power of 2 to be removed. And when I enter one side, I must do to the other. The square root of QT plus R. So the square root of P squared becomes P. And this is equal to the square root of QT plus R. And this is us expressing P as the subject of the formula, making P stand alone. Let's look at another. Make X the subject of the formula. So to make X the subject of the formula, what are we going to do? This is the same as Y is equal to X all over 5 plus 3P. And to make X the subject of the formula, again, once we have a formula or an equation where fractions are involved, our first step will be to remove the fraction. So to remove the fraction, first we can remove 3P if you wish. So you can take positive 3P and bring it over to the left, and it comes across the left as negative 3P, or if not, we can subtract 3P from both sides. The opposite of addition is subtraction. If I subtract 3P from itself, I'm going to get 0. So therefore 3P on the right will be removed. But with an equation, what you do to one side, you must do to the other. So I'm going to subtract 3P from Y. So my 3P is on the right, 3P subtract 3P is 0. I'm going to be left with X over 5 on the right hand side is equal to Y subtract 3P. Again, Y subtract 3P, I can express that as a fraction. I can put Y plus 3P over 1. And remember, you never solve an equation with fractions. But if you have one fraction on the left, one fraction on the right of the equal sign, to remove it from the fraction form, what we can do is to carry out something called cross multiplication. So I'm going to multiply, cross multiply, and we are going to get here. Again, it doesn't matter what side it's on, the aim is to make X the subject, so 1 by X will be X. So I'll put X on the left is equal to 5 multiplied by Y subtract 3P. So if I'm multiplying 5 by y subtract 3p, if I'm multiplying a number by an expression, it's important to place the expression in brackets. And therefore, I have x as the subject of the formula. This is the aim, to make x the subject. And we have done so. If you want to remove the brackets, to express it as x is equal to 5y minus 15p, no problem. Any one of the two is acceptable. So what we have done here is to make x the subject of the formula. So let's look at another one. So, the formula for the volume of a cylinder is given by V is equal to pi r squared h. And we want to make r the subject of the formula, which means we want to get r by itself on one side of the equal sign. So we have V is equal to pi r squared h. And how are we going to make r the subject? Now, of course, to make r the subject, all the variables that surrounds r we want to remove. So from your pi, your h, and the power of 2. So what we want to do is to remove pi and h first. This is pi multiplied by r squared multiplied by h. And we know that the opposite of multiplication is division. So this is pi r squared h and divided by pi h. So my two pi's will divide into each other to give 1. My two h's will divide into each other to give 1. And I'm going to get r squared by itself. But what we do to one side, we must do to the other. So I must divide v by pi h as well. So this becomes r squared is equal to v over pi h. And therefore to make h or to make r the subject, it means I have to remove the power of 2, and removing the power of 2, I'm going to find the square root of both sides. So this will be the square root of r squared. I place the square root symbol above r squared. And what I do to one side, I must do to the other. I place the square root symbol above v over pi h. So the square root of r squared, that becomes r. And the aim is to make r the subject of the formula, which is equal to square root of v over pi h. Okay? So this is us making r the subject of the formula. So let's look at another. So our aim is to make h the subject of the formula. So how are we going to make h the subject of the formula? We have d is equal to the square root of 4h all over 5. And what are we going to do here? Of course, our first step is to remove the square root symbol so we can get h as the subject of the formula. So to remove the square root symbol, what we're going to do is to find the square of both sides. So removing your square root symbol, you must find the square of both sides. So I'm going to find the square of d, and I'm going to find the square of the square root of 4h over 5. Once I find the square of the square root of 4h over 5, that square root symbol will automatically be removed. And this will become 4h over 5. So to remove the square root symbol, you must find the square of both sides. And of course, this is 4h over 5 is equal to d squared. Of course, I never solve or work with an equation or formula involving fractions. So the aim is to remove the fractions. So what do? I'm going to put d squared over 1, and to remove the fraction, we're going to cross multiply. So in cross multiplying, I'm going to get 4h is equal to 5d squared, and therefore to make h the subject, I'm going to remove my 4 in front of h, so the opposite of multiplication is division. So I'm going to divide 4h by 4, and what I put to one side I must do to the other. So I'm going to divide 5d squared by 4. So my two 4's divide each other to give me 1. H stands alone, and this is equal to 5d squared all over 4. So h as a subject is equal to 5d squared all over 4. And that's us making h the subject of the formula. Alright, so let's look at another. So we want to make v the subject of the formula. We have p is equal to the square root of 5 plus vt. So how are we going to make v the subject of the formula? So our first step will be to remove the square root symbol, and again, to remove a square root symbol, we're going to find the square of both sides. So what I do to one side, I must do to the other. So the square of the square root of 5 plus vt, once I find the square of the square root symbol will automatically be removed, and I'm going to be left with 5 plus vt is equal to p squared. And of course my aim is to make v the subject of the formula, so I'm going to remove 5 and I'm going to remove t. So I'm going to remove 5 first. So we know that the opposite of addition is subtraction. This is positive 5. So therefore, I'm going to subtract 5 from both sides. What I do to one side, I must do to the other. So my two 5's on the right cancels to become 0. I'm going to be left with vt is equal to p squared. Subtract 5. And therefore, to make v the subject, it means I have to remove t. So that's v multiplied by t. So the opposite of multiplication is division. So this is vt divided by t. The aim is to make v the subject, so I'm going to divide vt by t. And what I do to one side, I must do to the other. So I'm going to divide p squared minus 5 by t as well. So when my two t's divide into each other to get v1, v stands alone, or v is now the subject, which is equal to p squared minus 5 over t. And that's me making v the subject of the formula. So let's get into simultaneous equations. So simultaneous equations solve a pair of linear equations simultaneously. So we have here the pair of equations. We have 5x plus 6y is equal to 37, and we have 2x plus 3y is equal to 4. Again, CSEC asks for questions, and we want to solve the pair of equations simultaneously. So again, for us to solve a pair of equations simultaneously, we can use either the method of elimination or the method of substitution, any one of the two. And we know the objective when we solve a pair of equations simultaneously, the objective is to solve for x and y, the unknown quantities. So I'm going to use the method of elimination to solve the pair of equations simultaneously. So our first step will be to label both equations. So this is equation 1. That is equation 2. And what I'm going to do is to eliminate the x variable first. Now you can eliminate y first, it's up to you. I like to eliminate the first variable x. In this case, whatever leaves, I like to eliminate that variable. So I'm going to eliminate x. So to eliminate x, I must ensure first that the numbers in front of x are the same. So they are called the coefficients of x. You want to make sure that those two numbers or the coefficients of x are the same. Currently they are not. So to make them the same, what we want to do is to get the first, what's the lowest common multiple of 5 and 2? The lowest common multiple of 5 and 2 is 10. So let's make both numbers located in front of x 10. So how do I make my 5 in front of x 10? It means I have to multiply equation 1 by 2. And how do I make the 2 in front of x 10? It means I have to multiply equation 2 by 5. So I'm going to get two new equations which I'm going to label equation 3 and equation 4. So let me multiply all the terms in equation 1 by 2. So 5x by 2 will give me 10x. Plus 6y by 2 is plus 12y. And 37 by 2, that will give me 7 2 14, 74. Yeah? And let me multiply equation 2 by 5. This is 2x by 5, which is 10x. Plus 3y by 5 plus 15y is equal to 4 by 5, which is 20. So I have two new equations that I'm going to label equation 3 and equation 4, where the numbers located in front of x now, the coefficients of x now are the same. So it's easy for me to eliminate the x variable because I can subtract both equations to eliminate my x variable. And you know when you're going to subtract, because to eliminate you can add or subtract. You will normally subtract when, after making two numbers in front of the selected variable, the variable you have selected to eliminate, after making those two numbers the same, if the signs in front of those two numbers you have made the same are the same, then you will subtract. If the signs in front of those two numbers that you have made the same are different, then you add both equations. So our signs in front of the two numbers we have made the same are the same. Two positive signs are understood, so we can subtract both equations. And what I always encourage students to do is to follow through with the subtraction sign. And what I do next is to draw a line. And let's subtract. 10x subtract 10x is 0. So my x variable is eliminated. Just as I see it here vertically, I'm going to write it horizontally, meaning I'm going to state this as positive 12y is the same as 12y. I have my subtraction sign, subtract positive 15y is the same as 15y. So this is 12y subtract 15y. It is equal to 74 subtract 20. And 12y subtract 15y, that will give me negative 3y. And 74 subtract 20, that will give me 54. And therefore, to make y the subject, remember the aim is to solve for x and y, the negative 3 in front of y must be removed, and we know that the opposite of multiplication, it is division. So I'm going to divide negative 3y by negative 3, and what we do to one side of the equal sign, we must do to the other. So I'm going to divide 54 by negative 3. So when my two negative 3's on the left divide into each other to give me 1, y stands alone. And this is 54 divided by the negative 3. A plus divided by a minus is a minus. And when I divide 3 into 54, 3 into 5 is 1 remainder 2. And 3 into 24 will give me 8. So I have negative 18 as the value of y. But remember, we also have to find x. So how are we going to find x? So to find x, this is what we do. We're going to substitute. So I'll continue here. Substitute y equal to negative 18 into any one of the original equations. You pick one or two, right? So I'm going to substitute y equal to negative 18 into any one. I'll pick equation 2 into equation 2. So I state equation 2, which is 2x plus 3y is equal to 4. And where I see y in that equation, I'm going to replace that y with negative 18. So this will be 2x plus 3, and I replace y with negative 18, so I put negative 18 in brackets, is equal to 4. And this will become 2x plus 3 by negative 18, a plus by a minus is a minus. And 3 by 18 will give me 54. So I have negative 54 is equal to 4. And therefore, to make x a subject, what am I going to do? I have to remove negative 54, so I'm going to add 54 to both sides. So this is 2x minus 54 plus 54 is equal to, what I do to one side, I do to the other. This will be 4 plus 54. So negative 54 plus 54 on the left will be 0. You're going to have 2x is equal to 58. And then to make x a subject, I'm going to divide both sides by 2. And therefore, when my two 2's on the left divide with each other to give me 1, x stands alone, which is equal to 58 divided by 2 will give me 29. Good? So I can state at the end after I found my value for x and y, therefore x is equal to, my 3 dots there means therefore x is equal to 29 and y is equal to negative 18. So solving the pair of equations simultaneously, the pair of linear equations simultaneously using the method of elimination. Alright? Let's look at another. So let's solve the pair of equations simultaneously. This time I'm going to use the method of substitution. So I'm going to erase. So let's solve the pair of equations simultaneously using the method of substitution. So we have here 2x plus y is equal to 3, and we have 5x subtract 2y, it is equal to 12. So we want to solve the pair of equations simultaneously, but this time I'm using the method of substitution. So again, the first step is to label equation 1, 2, and in using the method of substitution, I'm going to choose a variable, choose an equation, and from that equation I'm going to make either the x or y variable the subject of the formula. So of the two equations, I will proceed to make y the subject of the formula in equation 1, because when I make y the subject of the formula in equation 1, the expression I obtain for y will be in a non-fraction form. And you try to avoid the fraction where possible. So in this case, I'm going to make y the subject of the formula, choosing equation 1. So I'm going to say from equation 1, I'm going to make y the subject of the formula. So I have 2x plus y is equal to 3. Let me make y the subject of the formula. So to make y the subject of the formula, I'm going to remove 2x, and because it's positive 2x, I'm going to subtract 2x from both sides. So it's going to be 2x subtract 2x plus y is equal to 3 subtract 2x. So when my 2x on the left cancels out to become 0, y is now the subject, which is equal to 3 subtract 2x, and I'm going to call that equation 3. So I've chosen equation 1, and I've made y the subject of the formula. And if you look, the expression obtained for y is not in a fraction form. So you try to avoid the fraction where possible, if you can. If you can't, you have no choice but to work with it, but the same steps will apply. So what are we going to do? We are going to substitute equation 3, this equation 3 here, into the equation that was not used to obtain equation 3. So we use equation 1 to obtain equation 3. These two equations are the same. So I'm going to substitute equation 3 into the equation that was not used to obtain equation 3, and that is equation 2. So I'm going to substitute equation 3 into equation 2. So I state equation 2, which is 5x, subtract 2y is equal to 12, and I'm going to replace this y in equation 2 with 3 minus 2x. See, y is equal to 3 minus 2x. So when I see y in equation 2, I'm going to replace it with 3 minus 2x. So this will be 5x, subtract 2, and in brackets, I'm replacing y with 3 minus 2x is equal to 12. And what I'm going to do now is to solve this equation. This is an equation strictly in terms of x. And let me solve an equation to find the value of x. So this will be 5x. Positive negative 2 by positive 3 will be negative 6. And negative 2 by negative 2x will be positive 4x is equal to 12. So let me solve for x. I'm going to, on the left, group like terms. So this will be 5x plus 4x subtract 6 is equal to 12. 5x plus 4x will be 9x. Subtract 6 is equal to 12. And I'm going to now remove negative 6 by adding 6 to both sides. I always do the opposite in operation. So it's negative 6. I have to add 6 to both sides. This is 9x. Subtract 6 plus 6. And when I do to one side, I do to the other. This is 12 plus 6. So we're going to get here negative 6 plus 6 on the left will be 0. So I'm going to have 9x is equal to 12 plus 6 will be 18. And therefore, to make x a subject, I'm going to divide both sides by 9. 9x all over 9, 18 all over 9. And therefore, x is equal to 2. So I found my value for x. And after I found the value of x, what I have to do is to find the value of y. So this is where I'm going to substitute. So we're going to substitute x equal to 2. You're going to substitute x equal to 2 into equation 3. Tell us to find the value of y. So therefore, equation 3, make sure it's stated, y is equal to 3 subtract 2x, and where I see x, I'm going to replace it with 2. So this is y is equal to 3 subtract 2, I'm going to replace x with 2 in brackets, y is equal to 3, subtract 4, and therefore y in this case is equal to negative 1. So therefore, x is equal to 2 and y is equal to negative 1. So I found the value of x and I found the value of y using the method of substitution. So making sure that we understand how to solve using the method of elimination and also the method of substitution. Yeah? Let's look at another. So of course, you can see your simultaneous equations in the worded format. So you have here one pack of biscuits costs X dollars and one cup of ice cream costs Y dollars. So a pack of biscuits, so 1 pack of biscuits that is equal to X dollars and 1 cup of ice cream that is equal to Y dollars. Good? Now, it states 1 pack of biscuits and 2 cups of ice cream cost $8, while 3 packs of biscuits and 1 cup of ice cream cost $9. They want us to write a pair of simultaneous equations in X and Y to represent the information given above. So, if 1 pack of biscuits and 2 cups of ice cream cost $8, we know 1 pack of biscuit, the cost of a pack of biscuits is X dollars, and if it's 1 pack, then the cost of that 1 pack will be X dollars. And 2 cups of ice cream cost, of course, 2 cups of ice cream and 1 pack of biscuit, the total cost is $8. But 2 cups of ice cream, if 1 cup of ice cream is Y dollars, then 2 cups of ice cream will be 2 Y dollars. So the total cost of 1 cup of ice cream, 1 pack of biscuits, sorry, and 2 cups of ice cream, total cost that is equal to $8. So one equation is created. Second, it states while 3 packs of biscuits, so if 1 pack of biscuit it's X dollars, then 3 packs will be 3X dollars. 3 packs of biscuits and 1 cup of ice cream, of course, a cup of ice cream is Y dollars, it's 1 cup, so that is going to be Y dollars. Total cost of 3 packs of biscuits and 1 cup of ice cream, that is equal to $9. So you have our second equation created. And they want us to, so this is part 1 answer. So you have created our pair of simultaneous equations. Now part 2, they asked us to solve the equations obtained in B part 1 above to find the cost of 1 pack of biscuits and 1 cup of ice cream. So let's get the cost of 1 pack of biscuit and 1 cup of ice cream. So easy. So we want to find X, we want to find Y, we solve the pair of equations simultaneously. How are we going to do so? Again, I'm going to use, you can use either the method of elimination or substitution. I'll go to elimination. So I'm going to part 2, state my pair of equations. I'm going to, of course, label equation 1, equation 2. I want to eliminate, I'm going to eliminate using the method of elimination. I'm going to eliminate the X variable. I like to eliminate the first variable, X, a variable to lead. So let me make sure the numbers in front of X are the same. Currently they are not. So the lowest common multiple of 3 and 1 is 3. So let me make both numbers in front of X 3. So I'm multiplying equation 1 to make this 3. 1 is obviously in front of X to make it 3. I have to multiply equation 1 by 3. And for this to remain as 3, I have to multiply equation 2 by 1. So we're going to get 2 new equations, which will be 3x plus 6y is equal to 24. And I'll call that equation 3. And let me multiply equation 2 by 1. This will be 3x by 1 is 3x. 1 by y is y. And 9 by 1 is 9. And I call this equation 4. The two numbers in front of x are now the same, and the signs in front of those two numbers are also the same, which means we're going to subtract both equations. So I like to follow through. I advise students to follow through with the subtraction sign. And we're going to get here what? 3x subtract 3x, that's 0. And what I see here vertically, I'm going to write horizontally. This will be 6y subtract y. Positive 6y is the same as 6y. You have the subtraction sign. Plus y is the same as y. And of course, you have 6y subtract y. It's equal to 24 subtract 9. What you see vertically, you write horizontal. So 6y subtract y is the same as 5y. and 24 subtract 9, that will give me 15. And what are we going to do here? Of course, to make y the subject, I need to remove the 5 in front of y, so the opposite of multiplication, it is division, so that's 5y divided by 5. And what I do to one side, I must do to the other, I divide 50 by 5. So my two 5s on the left divide into each other, so give me 1, y stands alone, and 5 into 50 will give me 3. So it will tell us here that 1 cup of ice cream is equal to $3. Of course, we'll state that at the end of our solution. So after we have found y, let us find x using the method of elimination. So we are going to substitute y equal to 3 into any of the original equations. You pick one, it doesn't matter, you get the same result. I'm going to substitute it into equation 2. So I'm going to substitute y equal to 3 into equation 2. I state equation 2, which is 3x plus y is equal to 9. And where I see y in equation 2, I'm going to replace it with 3. So this is 3x. I'm replacing this y with 3 plus 3 is equal to 9. And I'm going to now make x the subject of the formula by subtracting 3 from both sides. So I do 3x plus 3 subtract 3, 9 subtract 3. So of course, my 2 3's on the left will cancel out. I'm going to get 3x is equal to 6. And therefore, to make x the subject, I divide both sides by 3. X is equal to 2. So what we have done here is we have found the cost of a pack of biscuits. Of course, biscuits will be x. So the cost, we always state that here, therefore, the cost of 1 pack of biscuits, which is x, that is $2. And the cost of 1 cup of ice cream, the cost of 1 cup of ice cream, which is y, that is equal to $3. So we found the cost of 1 pack of biscuit and the cost of 1 cup of ice cream, solving both simultaneously, ensuring that we recognize when we have to solve simultaneously a pair of equations, but in the rooted form. Let's look at another. So a candy store packages lollipops and toffees in a bag for sale. So you have X grams representing, I guess that would be your lollipops, and your Y grams would be a toffee. So 5 lollipops and 12 toffees have a mass of 61 grams. 10 lollipops and 13 toffees have a mass of 89 grams. If the mass of one lollipop is X grams, so lollipop is equal to X grams, and the mass of one toffee, a toffee is equal to Y grams, write two equations in X and Y to represent the information. So 5 lollipops and 12 toffees, total mass 61 grams. So we know if we have 5 lollipops and we have X grams, so the total grams of those 5 lollipops will be 5x. And we have 12 toffees. Of course, you know that the mass of 1 toffee to y grams. You have 12 toffees, so the total mass of those 12 toffees will be 12 y grams. And therefore the total mass of your 5 lollipops and the 12 toffees, that is equal to 61 grams. Whereas you have 10 lollipops and 13 toffees, you have a total mass of 89 grams. Again, you know that the mass of 1 lollipop is x grams. You have 10 lollipops, so that will be a total mass of 10x grams for your 10 lollipops. Similarly, your 13 toffees, 1 toffee, it's y grams for 1 toffee. You have 13 of them, so the total mass of the 13 toffees will be 13 y grams. And therefore the total mass of your 10 lollipops and your 13 toffees is equal to 89 grams. So what we want to do here is calculate the mass of 1 lollipop and 1 toffee. So it means you have to solve them simultaneously. So what we have done in part 1 is to create a pair of linear equations which we are now going to solve simultaneously to help us to find the mass of 1 lollipop, which is x, and 1 toffee, which is y. Good? So, what we can do here, and I'll use a method of substitution here, where we will see how to use fractions when we make any one of the variables a subject. Right? So let's look at the method of substitution so we can see how to treat it where fractions are involved. So 1, I label 1, 2. So the second step is to choose an equation and we're going to make x or y the subject of the formula. So I will choose equation 1, and it doesn't matter which one of the variables you make the subject, the expression you're going to obtain for it will be a fraction. You can't avoid it in this case. So let's choose any one. I'm going to say from equation 1, I'm going to make x the subject of the formula. So I have 5x plus 12y is equal to 61. And let me make x the subject of the formula. It means I'm going to remove positive 12y first by subtracting 12y from both sides. And when my two 12y's on the left cancel to become 0, I will be left with 5x is equal to 61, subtract 12y, and therefore to make x the subject, I'm going to divide both sides by 5. So my two 5's on the left divide into each other to give me 1. X stands alone. And x is equal to 61 subtract 12y over 5. Alright, and that's me making x the subject, which I call equation 3. But what I want to do now, I want to substitute equation 3 into the equation that was not used to obtain equation 3. So the equation that was not used to obtain equation 3 will be equation 2, because I used equation 1 to help me to find equation 3. So these two equations are the same. So I'm going to substitute equation 3 into equation 2. So let me do so. So I'm going to substitute equation 3 into equation 2. And what are we going to get? I state equation 2. Equation 2 it is 10x plus 13y is equal to 89. And where I see x in equation 2, I'm going to replace it with 61 minus 12y over 5. So this will be 10, open brackets, I'm replacing x with 61, subtract 12y over 5, plus 3y plus 13y, sorry, is equal to 89. Yeah, so this is me substituting equation 3 into equation 2. Now when we look at this equation, we see fractions. And our aim is to always remove the fraction. We want to remove the fraction. We never solve an equation involving fractions. And currently we have 3 fractions in this equation. This is one fraction here, including a 10. 13y is a fraction. 89 is a fraction. 89 over 1. 13y over 1. So we have 3 fractions. So to remove the fraction, we know that the LCM of 5, 1, and 1, it is 5. And to remove the fraction, you're going to multiply each one of those fractions by the LCM 5. So the LCM of 5, 1, and 1 is 5. So I multiply this first fraction by 5. Plus, I'm going to multiply the second fraction by 5. Is equal to, I'm going to multiply the third fraction by 5. So I'm multiplying each fraction by the LCM, which is 5, right? So what's going to happen here? 5 into 5 is 1, 5 into 5 is 1, so we're going to be left with 10 into 61 minus 12y. Plus, this is 5 by 13y, that will give us 65y, is equal to 5 by 89, 9 5s are 45, 5 8s are 40, and 4 44. Yeah? So we have 89 by 5, let's double check. Right, so we get 445. So what we have here is an equation where no more fractions are involved. So let us solve this equation. So I'm going to remove my brackets. 10 by 61 will be 610. Subtract 10 by 12y will be 120y. Plus 65y is equal to 445. Using the method of substitution, but showing where when we make equation 3, when we find equation 3, making whatever variable x or y the subject, and the expression we obtain is a fraction, how do we treat with it? So let us solve this equation. Of course, this will be 610 negative 120 plus 65 will give us negative 55y is equal to 445. I'm going to remove my 610 by subtracting 610 from both sides. So this is negative 55y is equal to 445 subtract 610. So what I do to one side, I do to the other. I subtract 610 from both sides. I'm going to get negative 55y is equal to 445 subtract 610, which will give me negative 165. And therefore, to make y the subject, I'm going to divide both sides by negative 55. So this will be negative 55y divided by negative 55. And what I do to one side, I must do to the other. I divide negative 165 by negative 55. So negative 165 divided by negative 55 will give me 3. So y is equal to 3. Yeah? So it means that 1 toffee will be equal to 3 grams. Of course, we state that at the end. So let us find x. So I'm going to substitute y equal to 3 into equation 3, so I can easily find x. Into equation 3, so x will be equal to 61, subtract 12y over 5, so I'm going to replace y with 3. So this will be x is equal to 61 minus 12, and I'm going to replace y with 3, which I put in brackets, over 5. X is equal to 61, subtract 36 over 5, and this will be 61 subtract 36 is equal to 25, and 25 divided by 5 will give us 5 grams. So the mass of one lollipop is equal to 5 grams, and the mass of one toffee is equal to 3 grams. And make sure we state that at the end. Therefore, mass of one lollipop equals 5 grams, and the mass of one toffee is equal to 3 grams. Okay? So solving the pair of equations simultaneously. Again, we have the equations solving simultaneously in the worded format. So we'll use that to create our pair of equations, and then we can use either the method of elimination or the method of substitution to solve to achieve the unknown quantities. Okay, so let's move on to another. So looking at variation, I want to make sure you understand variation. So note there are two types of variations. You have direct variation and you also have inverse variation. And if they indicate in your question, you're showing the relationship between two variables. So if we talk about y varies directly as x, y varies directly as x, we can write or establish an equation between these two variables, which is y is equal to kx. K is known as your constant or proportionality. And if we talk about y varies inversely as x, then we can establish an equation between those two variables showing an inverse proportional relationship. That is, y is equal to k times 1 over x. So that's your inverse variation. And we can also simplify that or represent it as y is equal to k over x. So k is the same as k over 1. K by 1 is k, 1 by x is x. Right? So we have, let's show a quick example of direct variation, the relationship between two variables. Understand that this is your constant of proportionality, and the equation established for a direct variation relationship. And have inverse variation, where we have the constant of proportionality involved, show the relationship between the two variables, and we express it as y is equal to, if it's y is varies inversely as x, y is equal to k times 1 over x, or y is equal to k over x. So let's look at some questions here involving variation, direct and inverse. So we have here the table below shows corresponding values of the variables x and y, where y varies directly as x. So y varies directly as x. Good? They want us to calculate the values of a and b. So we have this table here, x, and we have y. And what we have to do when we talk about variation, we have to establish an equation between two variables in that relationship. So if they talk about y varies directly as x, we are going to establish our equation is y is equal to kx. Remember, k is known as your constant of proportionality. But the first thing we need to find in order for us to determine what is a and b, we need to find k. We need to find that constant of proportionality, which can be easily obtained because if you look at this table, when x is 2, the corresponding value of y is 12. So we can use x equal to 2 and y equal to 12 to help us to find k. So this will be simply replacing y with 12 is equal to k times x, which is 2. This is the same as 12 is equal to 2k. And I can make k the subject by dividing both sides by 2. So this is 2k over 2, 12 over 2, k is equal to 6. So the constant of proportionality between the variables x and y in a relationship is 6. So let us use this now to help us to find a and b. So very simple now. So again, we're using this equation established between the two variables, y is equal to kx. Now, when x is 5, the corresponding value of y is 8. So I'm going to replace y with 8. I'm going to replace k with 6 times, I'm going to replace x with 5. So that's k multiplied by x. Of course, k is 6, x is 5, that's 6 multiplied by 5. Brackets means multiplication. So a is equal to 30. Let us find b. So again, we're going to establish, using our equation for a direct proportional relationship, right? That relationship between b and 48. When x is b, the corresponding value of y is 48. So we can state here y is equal to kx. So where I see y, I'm going to replace it with 48. Where I see k, I'm going to replace it with 6. And where I see x, I'm going to replace it with b. So that is 6 multiplied by b, or 6b. And therefore, to make b the subject, I need to remove 6. So this is 6b divided by 6. And the opposite of multiplication is division. 48 divided by 6. 6 into 48 will be 8. So b will be equal to 8. So therefore, when a is, of course, when we found k, we were able to now determine what is the value of a, which is 30, and what is the value of b, which is 8, from our direct proportional relationship. Let's get another. Two variables x and y related such that y varies in this as the square of x. The square of x. Write an equation in x, y, and k to describe the inverse variation, where k is the constant of variation or constant of proportionality. So it states here y varies inversely as the square of x. The square of x will be x squared. So that is the square of x squared. And we can establish an equation showing an inverse proportional relationship between two variables y and x squared. And that is, for part A, y is equal to k times 1 over x squared, which is the same as y is equal to k over 1. K by 1 is k, 1 by x squared is x squared. So what we have here is an inverse proportional relationship between the two variables y and x squared, and the equation created showed the relationship between the two variables. Now B, using the information in the table above, calculate the values of k, r, and f. So we can easily find k by using the fact that when x is 3, the corresponding value of y is 2. So where I see y in my equation established initially, I'm going to replace this y with 2 is equal to k over, I'm going to replace x with 3 in bracket squared. So I'm going to get here 2 is equal to k all over 3 squared, it is 9, so I have 9. And what we can do is to find 1, which is k, we can find k. So you have an equation, when you have an equation with 1 fraction on the left, 2 is the same as 2 over 1 fraction on the right, k over 9 is a fraction, and what we can do here to remove it from the fraction form is to cross multiply. Once you have 1 fraction on the left, 1 fraction on the right, cross multiplication can occur. So 1 by k will give me k, 9 by 2 is 18. So I found the value of k, part 1. Now let's look at part 2, so B part 1. B part 2, let's find r. So to find r, what are we going to do? Again, we're using the equation established initially, y is equal to k over x squared, and to find r, when x is 1.8, the corresponding value of y is r, so I'm going to replace y with r, is equal to k, I'm going to replace k with 18, over, I'm going to replace x with 1.8, in bracket squared. So r is equal to 18 all over, let's look at this 1.8 squared, 1.8 by 1.8, that will give us 3.24. And let's divide 18 by 3.24. Alright? So we're going to get r as 5.5. 5, and I'll express it to 1 decimal place, or even 3 significant figures. I'll express it as 5.56 to 3 significant figures. So that is the value of r. So when k is 18, replace k with 18, we know when x is 1.8, y is r, the corresponding value of y is r. To replace y with r, we replace x with 1.8 in the equation established initially to find your value of r. Let's do the same for part 3. Let's find f. So again, we use the equation established initially. And what are we going to do? When x is f, the corresponding value of y is 8. So I'm going to replace y with 8 is equal to k. I'm going to replace k with 18 over, I'm going to replace x with f squared. So what are we going to do? So we need to find f. The first thing we need to do is to remove it from the fraction form. Never solve an equation with fractions, but you have 1 fraction on the left, which is 8 over 1 fraction on the right, 18 over f squared. So to remove it from the fraction, we can cross multiply. So I'm going to get 8 by f squared will be 8f squared. Remember, this can be written on the left or the right side of the equal sign, it doesn't matter. And 1 by 18 will give us 18. And therefore, to get f squared by itself, I need to remove the 8 in front of f squared. So the opposite of multiplication is division. This is 8f squared divided by 8. And what I do to one side, I must do to the other. I divide 18 by 8. My two 8s on the left will divide into each other to give me 1. I'm going to have f squared is equal to 18 all over 8. And you can convert it into decimal if you wish. That's 2.25. And therefore, to get f by itself, I need to remove the power of 2. So I'm going to find the square root of both sides. This is f squared. So the square root of f squared becomes f. And the square root of 2.25 will be what? 1.5. So I found my value for R and I found my value for F using an inverse proportional relationship. Let's look at another. So variation, let's get familiar with the topic variation. Direct and inverse variation. Now the table below shows corresponding values of the variables x and y, where y varies directly as x. Y varies directly as x. So again, once it's a direct proportional relationship, direct variation, we establish an equation. That equation is what? Y is equal to kx. And what we want to do is to determine the values of t and u. So again, when x is 6, the corresponding value of y is 3. So I'm going to replace y with 3, k times I'm replacing x with 6. So this is the same as 3 is equal to 6k, and therefore I can divide both sides by 6. But my two 6's cancels, k is equal to a half. And after I found k, let me find u and t. So very straightforward. Again, I'm using the equation established. Y is equal to kx. And when x is 10, the corresponding value of y to u. So I'm replacing y with u. I'm replacing k with a half times I'm replacing x with 10. So u is equal to a half by 10, which is 5. So I found the value of u. Let me find the value of t. So to find t, what do we do? Again, using our relationship, y is equal to kx. And when x is t, the corresponding value of y is 9. So I'm going to replace y with 9, k with a half, and x with t. So again, testing our knowledge of solving equations. Now a half times t, you can write this as 9 is equal to t over 2. 1 by t is t, 2 by 1 is 2. And to remove it from the fraction, because you have 9 over 1 and t over 2, to remove it from the fraction, you can cross multiply, because you have one fraction on the left, one fraction on the right of the equal sign. So 1 by t is t, 9 by 2 will give us 18. So, direct proportional relationship. Right? So let's jump into indices. So now with the indices, we have to make sure the laws of indices. There's a law of multiplication, division, the law when the power is 0, the law of what we call power to a power, the law of the negative index, and the law of the fraction index. Right? So you have to make sure you know our laws of indices. Okay? So just to quickly, the laws: multiplication, that is a to the power of m by a to the power of n. Once you have the same base, keep the base and add your powers. That's multiplication. Division, if you have a to the power of m divided by a to the power of n, and you can rewrite it as a to the power of m over a to the power of n, you keep the variable a and you subtract the powers. Always power of the numerator, subtract the power of the denominator. B, you have the law of the zero index. So if you have a base raised to a power of 0, that is equal to 1. So any base raised to a power of 0, that is equal to 1, you have the zero index. 4, you have what you call power to a power, meaning if you have a to the power of n raised to a power of n, you can simply take the power outside and multiply by the power inside. This is a to the power of n, multiplying the power outside by the power inside. You also have 5, the law of the negative index. So if you have a to the power of negative m, then when the power is negative, we can make it positive by writing it as 1 all over a, and negative m becomes positive m. And the vice versa, you can move from a positive index to a negative index. When you move a from the denominator, a to the power of m, from the denominator to the numerator, a base stays as is, but positive m becomes negative m. So the vice versa can be done. And 6, you have the fraction index, fractional index. So if you have a base and a power that's a fraction, then when you have a power that's a fraction, note the root symbol can come into play. So this is the root symbol. A base stays as is, but m, which is the numerator of the fraction index, becomes the power of a, and n, which is the denominator of the fraction index, becomes the order of the root. So this is the nth root of a to the power of m. And the vice versa can be done. You can convert this into a fraction index by simply, once you have the root symbol, this is the same as a, the power of am becomes the numerator of the fraction index, and the order of the root n becomes the denominator of the fraction index. So these are the laws of indices that you must remember, and of course we're going to apply to some questions that we're going to see from the CSEC past papers where indices are involved. So let me erase and let's look at some questions. So indices. So they ask us to simplify p to the power of 3, simplify p to the power of 3, q to the power of 2 times p q to the power of 5. So we're multiplying, note, p to the power of 3 by p to the power of 1. Once we're multiplying, we keep the base p and the powers we add. We're multiplying q to the power of 2 by q to the power of 5. We keep the base q and we add the powers. So we're going to get here p to the power of 4, q to the power of 7. That is our answer there when we are multiplying. Let's look at another simple multiplication again. We want to simplify. So this is 3p squared times 4p to the power of 5 So what we can do, we can multiply what we call coefficients. 3 by 4 will give us 12. And p to the power of 2 by p to the power of 5. When we are multiplying and we have the same base, we maintain the base and the powers we add. So we're going to get here 12 p to the power of 7. Yeah? Let's take another. So what is a simplified? So this is a combination of both multiplication and division. 4x squared times 3x to the power of 4 over 6x cubed. So let's work out what is in our numerator. So I can multiply the coefficients. 4 by 3 is 12. X to the power of 2 by x to the power of 4. We have the same base. We keep the base x and we add our powers. And of course, we have 4 over 6x to the power of 3. So we're dividing. So we can divide what we call coefficients. 12 divided by 6 will be 2. And we divided x to the power of 6 by x to the power of 3. So we keep the variable x. And we subtract our powers. 6 subtract 3. So we're going to get 2x to the power of 3 will be the final result. So we have a combination of both multiplication and division. So let's look at another example. So we have 3x to the power of 2 times 4x to the power of 3 over 2x. So let's work out what is in our numerator. So 3, we can multiply the coefficients. 3 by 4 is 12. X to the power of 2 by x to the power of 3, we keep the base x. And we add our powers over 2x. So we're going to get 12x to the power of 5 over 2x. And when we're dividing, applying the law of division of indices, 12 divided by 2 will give us 6. And x to the power of 5 divided by x to the power of 1 will give x. And we subtract our powers. 5 subtract 1, 1 is understood, will give us 6x to the power of 4. Applying our laws of indices. So let's look at another. We have to simplify 3 over 4y cubed divided by 21x squared over 20y squared. So how do we treat with such? When we're dividing, we keep the first, we go from our knowledge of division of fractions, we keep the first fraction as is, 3x over 4y cubed. You change your division sign to a multiplication sign. And you invert the second fraction, which will write as 20y squared over 21x squared. And what we can do, we can multiply, we can apply multiplication and division here of indices or laws. So you can see the question in this format. So you can multiply 3x by 20y squared. 3 by 20 will give us 60. And x by y squared is the same as x y squared. Over, let's multiply. 4 by 21 will give us 84. And y to the power of 3 by x to the power of 2 will be the same as x squared y cubed. So the reason why I wrote it in that format, so you can see x under x, y under y. So when you're applying your law of division, you see like variables under each other. So let's simplify 60 all over 84. That can be simplified to become 4 can go into 60, 15. And 4 can go into 84, 21. Also 3 can go into 15, 3 can go to 15, 5 over 3 to 21, 7. So 60 over 84 can be simplified to 5 over 7. X to the power of 1 divided by x to the power of 2. This is the same as x to the power of 1 subtract 2. So applying the law of division, which is 1 subtract 2, that will give us negative 1. Similarly, y to the power of 2 divided by y to the power of 3. Again, you're dividing, applying the law of division, keep y, and we subtract the power. So let's power the numerator, subtract power in the denominator. So this will be the same as 5 over 7, x to the power of negative 1, y to the power of negative 1. Now we can further simplify that by applying the law of the negative index here. The negative index. So this is the same as 5 over 7 multiplied by x to the power of negative 1. When you convert from a negative power to a positive power, this is 1 over x to the power of positive 1 times y to the power of negative 1. Let's convert that from a negative index to a positive index. This will be 1 over y, and negative 1 becomes positive 1. 1 is understood here, 1 is understood, both positive indices. And therefore, 1 we can write the final answer as in a proper format. Multiply all in your numerator. 5 by 1 by 1 is 5 over 7 by x by y, it is 7xy. And that is our answer there, simplified. Okay? So applying your laws of indices where applicable. Let's look at another. Right, so we want us to simplify 1. X to the power of 3 whole square. So this is the law of power to a power. So you're going to take the power outside and multiply by the power inside. So this will give us x to the power of 6. And let's look at 2. Y to the power of 8 divided by y to the power of negative 5. We can rewrite it as y to the power of 8 over y to the power of negative 5. And when you're dividing, remember what we do with the powers? We subtract the powers. So this is maintaining your base y. And we're subtracting the power. So this is 8 subtract the power negative 5. So I put negative 5 in brackets. So we're going to get here y to the power of 8 plus 5. And this will give us a y to the power of 13. Yeah? So making sure we can apply our laws of indices where applicable. Alright, let's look at another. So they want us to simplify 1, x to the power of 2 by x to the power of 3 divided by x to the power of 4. So let's carry out our multiplication first. This is x to the power of 5 divided by x to the power of 4. Remember when you're multiplying, we add the powers, and this will be x to the power of 5 over x to the power of 4. We can write it like that, which is the same as x to the power of 5 subtract 4, x to the power of 1 or x. Yeah? So very straightforward. And 2, a to the power of 3 over 2, b to the power of 5 over 2, multiplied by the square root of a to the power of 3. So very important how we treat with this question. So what are we going to do here? From the time we see this root simple, note we can convert that into a fraction, index, or power. Now, this is the same as AB to the power of 3. Power 1 is understood there. So I put ABQ in brackets, a power of 1 is understood. Now, we can rewrite this. Now, note the order of this root. It's not seen, but it's understood. 2 is understood here. It's the square root. 2 is understood. It's not seen, but it's understood. So we can rewrite this as a to the power of 3 over 2, b to the power of 5 over 2 times, this is the same as a b to the power of 3 in brackets all to the power of a half. So this root symbol here, the square root, and of course a, b, q in brackets are placed in brackets raised to the power of 1. So from the law of indices, if you're converting it back to the fractional power, note, you write a, b, q as is, of course maintain the brackets, but 1 becomes the numerator of the fractional index, 2, which is the order of the root, becomes the denominator of the fractional index. And what we're going to do here now is to apply power to a power here. A has a power of 1, it's understood, it's not seen. B has a power of 3. So we are applying the law of power to a power where I'm taking the power outside and I'm going to multiply by the power within. So this will become a to the power of 3 over 2, b to the power of 5 over 2 times, when we apply power to a power, a half by 1 is a half, so this is a to the power of a half, and a half by 3 becomes 3 over 2, b to the power of 3 over 2. So this is me converting the square root of a, b cubed into that form, fractional index. And now I can further simplify by using my law of multiplication. A to the power of 3 over 2 by a to the power of a half, I keep a and I add my powers. 3 over 2 plus a half. B to the power of 5 over 2 by b to the power of 3 over 2. I keep b and I add my powers. So this will be a to the power of 4 over 2, b to the power of 8 over 2, which will simplify to become a to the power of 2, b to the power of 4. And that will be the result there. So making sure we know our laws of indices and we can apply those laws to help us to simplify. Alright, so let's look at now functions and relations. So the last topic we're looking at today will be questions in relation to functions and relations, right? So with functions and relations, we need to understand that you can encounter questions where you have the substitution approach, you have the composite function combining two, and you have the inverse of a function. So in this question, CSEC past papers again, and don't forget to like, share, and subscribe to the channel. So we have here f of x is equal to 2x subtract 5, and g of x is equal to x squared plus 3. And they want us to calculate the value of f of 4. So we're going to find f of 4. F of 4 simply means, and focusing on the image of x, or the function f of x, which is 2x subtract 5, and where I see my x in that expression, I'm going to replace it with 4. So this will be 2 times 4 in brackets subtract 5, 8 subtract 5, which is 3. Straightforward. Then they want us to find gf of 4. So we're going to find gf of 4. This is what we call a composite function. And we want to find a value for gf of 4. Once you see a number in brackets, the answer will be a value. So to find gf of 4, I first must work out what is g of 4, which I did previously. G of 4 is 3. So this is really the same as g of 3. So gf of 4 is really g of 3. And what is g of 3? This is simple. Again, I'm focusing on g of x, whose expression is x squared plus 3. And where I see x, I'm going to replace it with 3. So this is 3 in brackets squared plus 3. 3 squared is 9. 9 plus 3 will give me 12. And that's the answer for gf of 4. So let's look at part 2, which is to find f inverse of x. So let's find f inverse of x. So when you see f to the power of negative 1, they ask you to find the inverse. So we have 2 f inverse of x. So I want to find the inverse of this function f of x. So how am I going to find the inverse? Again, for the inverse, which is represented with the function raised to the power of negative 1, there are 3 steps. The 3 steps are I let y, f of x and g of x both represent y, they both be y. So I let y be equal to 2x minus 5. So y equal to 2x minus 5. Then we do what? For our second step. This is your first step. Second step, you interchange x and y, meaning where I see y, I replace it with x, and where I see x, I replace it with y. So my first step is to make y the subject, let y be equal to 2x minus 5. My second step is to interchange x and y, so interchange them. And the third step is to simply make y the subject of the formula. So let's make y the subject of the formula, which means I have to make y standalone. This is where transposition will come into play. So what am I going to do? I'm going to add 5 to both sides. This is 2y. Subtract 5 plus 5. What I do to one side, I do to the other. I add 5 to x. So my negative 5 and positive 5 will cancel out. That's 0. So again, I'm going to get 2y is equal to x plus 5. And then I'm going to divide both sides by 2. 2y over 2. X plus 5 over 2. So my two 2's divided to each other to give me 1. Y stands alone, which is equal to x plus 5 over 2. And therefore I will state at the end that f inverse of x is equal to x plus 5 over 2. So that is how I find the inverse of my function, carrying out 3 basic steps. This is step 1. This is step 2. And this is step 3. So 3 basic steps. Alright? Let's look at another. Given we have some areas. Right, so you have f of x is equal to 2x plus 1 over 3, and g of x is 4x plus 5. Determine the values of 1, f, g of 2. So what do I need to do? I need to find g of 2. What is on the right? G of 2 first. And then I'm going to, after I work out G of 2, then I can find f of that value. So let's work out with G of 2. So G of 2 is simply replace my x in G of x with 2. So this is 4 times 2 plus 5. 8 plus 5, which is 13. That's the value of G of 2. So really what you're finding here, f G of 2 is really the same as f of 13. Because G of 2, we got that to be what? 13. So let's really find what is f of 13. So it means where I see my x in f of x, I'm going to replace it with 13. This will be 2 times 13 in brackets plus 1 all over 3. 2 by 13 is 26 plus 1 over 3, 27 over 3, and the answer there is 9. That is f in G of 2, the value formula. Now the third, we need to find f inverse of 3. So f inverse of 3, the second f inverse of 3. So 2 f inverse of 3. So first I need to find an expression for f inverse of x, and then I can find what is f inverse of 3. So let me find this first, f inverse of x. So how am I going to find f inverse of x? This is f of x, so I need to find the inverse of that function. So let me find the inverse. How many steps? 3 steps. First step, let y, remember f of x also means y, let y be equal to 2x plus 1 over 3. That's my first step. My second step is to interchange x and y. So where I see y, I put x, and where I see x, I put y. So that's interchanging. And then the last step is to make y the subject of the formula. So how am I going to make y the subject of the formula? Of course, I'm going to put x all over 1, 2y plus 1 over 3. And to make y the subject of the formula, remember you have one fraction on the left, one fraction on the right. So to remove the fraction, once you have one on the left, one on the right, you can cross multiply. So I'm going to multiply 1 by 2y plus 1 to give me 2y plus 1. And I'm going to multiply x by 3 to give me 3x. Then I'm going to subtract 1 from both sides. This will be 2y plus 1 subtract 1 is equal to 3x subtract 1. My 2 1s on the left will cancel out. So I'm going to get 2y is equal to 3x subtract 1. This is making y the subject. And then I'm going to divide both sides by 2. 2y over 2. 3x subtract 1 over 2. So my two 2's divided each other to give me 1. Y stands alone, which is equal to 3x subtract 1 over 2. And that is equal to f inverse of x. And after I've found f inverse of x, then I'm going to easily find f inverse of 3. So this is f inverse of x here. But now let us quickly find f inverse of 3. So what is f inverse of 3? It means where I see x in f inverse of x, I replace it with 3. So this is 3 times 3 brackets subtract 1 over 2. 3 by 3 is 9, subtract 1 will give me 8 over 2, whose answer is 4. So the answer for f inverse of 3 it is equal to 4. So first we find f inverse of x, and after we find f inverse of x, then we can find f inverse of 3. Alright, so let's look at another. Right, so let's look at this one here. The functions f of x and g of x are defined as follows. Let's find f of 5, f inverse of x, and of course g f of x. So let's treat with 1. So f of x is equal to 2x minus 7 over x, and g of x is equal to the square root of x plus 3. So let's evaluate 1, f of 5. So f of 5 means where I see x and f of x, I'm going to replace it with 5. So this is 2 times 5 in brackets minus 7 over 5. 2 by 5 is 10 minus 7 over 5. 10 minus 7 will give us 3 all over 5. So that is f of 5. 2. Write an expression for f inverse of x. So f inverse of x. So they want expressions. They want to see x in brackets. They want you to represent the answer as an expression. So how do we represent it as an expression in terms of x? We have to carry out 3 steps to find the inverse, which are, I'm going to let f of x be y is equal to 2x minus 7 over x. Then I'm going to what? Interchange x and y. So where I see y, I'm going to put x. Where I see x, I'm going to put y. And then the final step is to make y the subject. Of the formula. So we're going to make y the subject of the formula. Oh, sorry, put a y below here also. So remember you have 2 x's, so replace this x with y, replace that x with y. Now let's make y the subject of the formula, which means we have to get y by itself. A very important question, how are we going to make y by itself? Of course, we have here x over 1, 2y minus 7 over y. Let's CSEC pass with the question. And then you have one fraction on the left, one fraction on the right. What you must do is cross multiply to remove it from the fraction form. So when I cross multiply, I'm going to get here 1 by 2y minus 7, which is 2y minus 7. And x multiplied by y will give me xy. But to make y the subject, I have 2 terms involving y. 2 terms involving y. So all terms involving y, you make sure you put on one side. All terms that do not involve y, you place on the other. So this is 2y. Positive xy comes across as negative xy. And negative 7 comes across on the right as positive 7. But to make y the subject, I still have 2 terms involving y. I need 1 term involving y. To make that happen, I have to factorize this expression. And I will factorize by taking the y out as a common factor, and I'm going to divide y into each term. So y into 2y will give me 2. And y into negative xy will give me negative x. So this is me factorizing. Put y as a common factor, divide into each term, and that is equal to 7. And therefore, to make y the subject now, I am going to remove that 2 subtract x. So by dividing both sides by 2 subtract x. What I do to one side, I do to the other. So my 2 subtract x will divide into each other to give me 1. Y stands alone, and this is equal to 7 over 2 subtract x. And this is making y the subject of the formula, which is the last step when you find the inverse. And I can write this as f inverse of x is equal to 7 over 2 subtract x. And that is the inverse, the expression for the inverse of the function. Okay? Let's look at the other part. The other part, they ask you to find gf of x. So part B is to find gf of x. So this is 2a and 2b, an expression for gf of x. So we have to get an expression for gf of x. Good? What are we going to do? Again, that is a combination of 2 functions given. You have f of x by itself, g of x by itself. Gf of x is bringing the 2 together. So how do we do so? I will leave g as is. What is on the left? G stays as is. I'm going to replace f of x with the expression I have here, which is what? I'm going to put that in brackets. 2x minus 7 over x. But what is g of 2x minus 7 all over x? What is g of that? It is simply, if g of x is the square root of x plus 3, it means where I see x in this function, I'm going to replace it with 2x minus 7 over x. So this here is the same as the square root of 2x minus 7 over x plus 3. And we can leave it like that if you wish. So that there is the expression for gf of x. So we leave g as is, we replace f of x with the expression given, and therefore to find g of that expression in brackets, we are going to replace the x in your g of x, the expression for g of x, with 2x minus 7 over x to give us the final result, or representation for g of x. Alright? So, let's take another. Right, so we have 2 functions are defined by g of x is equal to 4x plus 3, and f of x is equal to 2x plus 7 over x plus 1. State the value of x, which f of x is undefined. So if f of x is undefined, very common question, we have to make sure you understand that. When a number or a function is undefined, it means that the denominator is 0. That is said to be undefined. Put that in the calculator, 2 divided by 0, you see error. So when the denominator is 0, it's undefined. So what value of x will make this function undefined? What value of x will make the denominator 0? And that's straightforward. The value of x that will make it 0. If you're not sure, you can just simply say left, take the denominator as if x plus 1 be equal to 0, and therefore x is equal to, I subtract 1 from both sides, x is negative 1. So when x is negative 1, this denominator becomes 0, and therefore the function is said to be undefined. Part 2, calculate gf of 5. Simple, we will find f of 5 first. by replacing my x in f of x, my 2x's in f of x with 5. This is 2 times 5 plus 7. This is 5 plus 1. So I'm going to get here 10 plus 7 over 5 plus 1, 17 all over 6. That is for g, that is for f of 5. So therefore, gf of 5 will be g of 17 all over 6. And what is g of 17 all over 6? It means where I see x in my g of x, I'm going to replace that x with 17 all over 6. So this will be 4, 17 all over 6 in brackets, plus 3. And when I simplify that, I'm going to get here, this will be, this will be 2 into 4, 2, 2 into 6, 3. I'm going to get 2 by 17 is 34 over 3 plus 3. And what I can do is I can put 3 over 1. I can find my LCM, or if not, I can multiply 1 by 3 and 3 by 3. This will give me 34 over 3 plus 9 all over 3. And that will give me 43 all over 3. Which is the same as 3 into 4 is 1, remainder 1. 4 3s are 12 and 1 13. 14 and a third will be the value for gf of 5. And let's find now the inverse of f. What is f inverse of x? So to find part 3, f inverse of x. So f inverse of x, carry out 3 steps. In all 3 steps, we let y equal to 2x plus 7 over x plus 1. Step 2, we interchange x and y. So where I see y, put x. Where I see x in those 2 places, I put y, 2y plus 7 over y plus 1. And then the last step is to make y the subject. Of the formula. So I'm going to put x over 1. And of course, I'm going to cross multiply, right? This as x over 1. So I'm going to cross multiply to remove it from the fraction form. So this is 1 by 2y plus 7. And again, it doesn't matter if it's on the left or right. And x by y plus 1, of course, I'm multiplying x by an expression. So I make sure I put that expression in brackets. It's going to be x, y plus 1. So I'm going to get 2y plus 7 is equal to xy plus x. And let's make y the subject. So I'm seeing 2 terms involving y. 2y on the left, xy on the right. So we put all my terms involving y on one side. So this is 2y. Subtract xy. Positive xy will come across to the left as negative xy. We subtract xy from both sides. Is equal to, put all terms that do not involve y on the right. This is x. Subtract 7. And then on the left hand side, to make y the subject, I have 2 terms involving y, I need 1. So to make that happen, I have to factorize. So I'm going to put out y as my common factor. Y is common, I take out y, divide y into 2y to give me 2. And divide y into negative xy to give me negative x. Is equal to x minus 7. And therefore, to make y the subject, I'm going to divide both sides by 2 minus x. So this will be y 2 minus x, I divide by 2 minus x. And when I go to one side, I go to the other, and divide x minus 7 by 2 minus x. So my 2 minus x divided each other to give me 1. Y stands alone. And therefore, I'm going to get here f inverse of x is equal to x minus 7 over 2 minus x. And that is the inverse of the function. Okay. Alright? Making sure we're clear on how to find the inverse, 3 basic steps. But of course, if you have 2 terms involving y on one side, you have no choice but to factorize so you can make y the subject of the formula. Alright? So, this will bring us to the end of this session today. Don't forget, every Saturday from now until exams, I'll be doing exercises, past paper questions on topics to help to prepare us for the exam. Don't forget to like, share, and subscribe to the channel. Make sure you share with everyone, share with your friends, share with family. Let's make sure that we can benefit from these sessions on a Saturday. Alright? So, take care everyone. Have a good evening. Take care.